All right, so today we're going to do a lesson on how to find the axis of symmetry in the vertex of a function. So last class, we talked about finding the axis of symmetry when you're given a graph. And you guys did a great job of identifying the axis of symmetry on a graph because remember, the axis of symmetry is the imaginary line that splits the parabola exactly in half, so right down the middle. So in my drawing here, it's this dotted line is the axis of symmetry. If the parabola is folded along the line, both halves would line up perfectly. Right? Think of something that's symmetrical is going to be even on both sides. So, and then once you were able to find the axis of symmetry is this point here. And your axis of symmetry is always going to be x equals some number. Because again, your axis of symmetry, this red line, is running right through your x-axis. So x equals some number is your axis of symmetry. We also talked about last class the vertex of a parabola. So the vertex is the highest or lowest point of a parabola. And it's always on the axis of symmetry. So we have two examples here. In this first example, on the top parabola, if I were to draw my axis of symmetry right through the middle of this parabola, I'm going to hit the parabola right here, this point here. This is going to be your vertex, and your vertex is always going to be an ordered pair, x, comma, y. Okay. In this example, our x would be 0 because we're not going left or right any, we're not going to the right any spots or left any spots. And then your y value would be however many spots you're going down. In the second example, again, we have our axis of symmetry. If I were to draw a line right through the middle, and your vertex is going to be the point that I'm drawing here, right here in black. That would be your vertex. And again, your vertex would be x comma y. This is how you find the vertex when you're given a parabola. But you're not always going to be given a graph. Sometimes you're just going to be given an equation, or a function we'll call it, and that's what we're going to get to. But let's just review real quick. So again, this is review from last class. Let's find the axis of symmetry in the vertex from a graph. So vertex, the vertex is either going to be your highest point or the lowest point on the graph. So either a maximum or a minimum. So here, our vertex is going to be this point right here. We have a maximum point. It's at the very top of our parabola. This point, we need an x and a y. So if we look at our x, our point is at 3. And if we look at our y, our point is at 4. So the vertex of this parabola is 3, 4. Good. All right, and the axis of symmetry. Remember, the axis of symmetry is that invisible line that cuts the parabola right in half. So if I were to draw a line, this is our axis of symmetry in blue. And remember, the axis of symmetry is just going to be x equals some number. Your axis of symmetry goes right through the x-axis. So what number is our axis of symmetry going through on the x-axis? That would be x equals 3. Great. All right. Now let's move on to how to find the axis of symmetry given an equation. In order to do that, we're going to need to use this formula here. This is an important formula you guys need to know. This is the formula you use to find the axis of symmetry. Remember, the axis of symmetry is always going to be x equals some number, and we're going to use this formula. X equals negative b divided by 2a. Now you might ask, where does the b and where did the a come from? Let's look over here at the right. We talked about last class the quadratic formula, remember it's ax squared plus bx plus c. A, b, and c, the variables a, b, and c are what change in each function. Those represent some number. If you look in the example here, we have 3x squared plus 12x plus 3. So this would be our a, this would be our b, and this would be our c, right? A, the number is always with x squared. B is the number with just the variable x. And then c is the number that's by itself. Okay. So again, a. So what I'm doing here is I suggest, just to help organize yourself, for each one of these type of problems, list out each part. So a is 3, b is 12, and c is 3. Great. Now we're going to need to use some of these numbers in order to find the axis of symmetry. We're going to need b and a, because those are part of the formula over on the left in the yellow box. We don't really necessarily need the 3 here because we're not dealing with c, but we'll need that later on. So let's look down here. So my directions say plug the numbers into the formula for the variable, and again, variable means letter, they go with. So again, our formula is negative b divided by 2a. Negative b. Look up top. What is our b? Our b is 12 in pink. So this is where the 12 goes, negative 12. So it's negative 12 over, or divided by 2a. What's going to go here in this red box? This is where your a value goes. Our a is 3. So we just set up the problem here, and now we need to solve, because remember, we just want x equals one number. So now you could plug this right into your calculator as long as you remember the parentheses in the specific spots, but you need to follow order of operations. So we need to multiply 2 times 3 down here first. 2 times 3 is 6. And then we can just take this negative and attach it onto the 12. So we have negative 12 divided by 6. Great. Let me just make my screen a little smaller. And then we just have a division problem here. We have negative 12 divided by 6 is negative 2. Perfect. So our axis of symmetry is x equals negative 2. All right, so now we need to find the y value of the vertex. Once you have found the axis of symmetry, which again is the x coordinate, you can plug it into the equation to solve for the y value of the vertex. So that's the word form, or the word directions. What do I mean by that? Let's look at the example here. So we're still working with the same function. You could think of the function like a rule. So we're still working with the same function. On the last page, we found that x equals negative 2. We got that negative 2 on this page here when we solved for the axis of symmetry. Now, in order to solve for y, remember your vertex is always a coordinate point. That's going to be x comma y. We only solved for x. Now we need to solve for y. So to do that, we need to take the number we got for x and plug it in to the function wherever there is an x, right? So I'm going to replace this x with a negative 2 and this x with a negative 2. So now we have 3 parentheses, negative 2 squared, plus 12 parentheses, negative 2 plus 3. Now we just need to solve. When you're solving, you could put this right in your calculator. You need to make sure you include the parentheses, but let's work it out. In order to solve this, we need to follow order of operations. which you guys know as PEMDAS, PEMDAS. And this is the order of operations in which you solve an equation. So P stands for parentheses. We don't have any operations inside the parentheses, so we're not going to do that. E is exponent. We do have an exponent. We have -2 squared, so we need to do that first. So I'm just going to bring down the 3. -2 squared is 4. And then I'm just going to bring everything else down. Plus 12 times -2 plus 3. So P, check, E. All right, next we have M. M stands for multiplication. So we need to do multiplication next. I see multiplication in 2 spots. We have 3 times 4, and we also have 12 times -2. 3 times 4 is 12. 12 times -2 is -24. And then I just brought down the plus 3. Now, we did multiplication. Put a check on that. There is no division. Addition and subtraction, that doesn't necessarily mean you have to do addition first and then subtraction. You do addition and subtraction the way you read. So just do it from left to right. So I'll actually make my arrow like this because that would mean we're going back and forth. So from left to right. So again, the way you read from left to right, you would just solve this equation this way. So you would be doing 12 minus 24 plus 3 to get -9. So now we have our x and we have our y, which means we have our vertex. Again, our x is -2, and our y we found is -9. So our vertex is -2, -9. Let's look at another example. Let's find the axis of symmetry. We now have a new function here. Again, your function serves as like your, think of it like a rule. You have to follow it. Let's see, our parts. What is our A, what is our B, and what is our C? In this function here, A, you could think of it too like A, B, C. In the alphabet, A comes first, then B, then C. In your function, A comes first, B is second, C is last. So in this example here, A is -3, B is 6, and C is 5. So now we're going to use the axis of symmetry formula to solve. And again, our axis of symmetry formula is right here. X equals -b over 2a. And when I say over, I mean division. So we need b in, let me change this here. I forgot to change it on. This, excuse me, this should say A. I forgot to change it on my PowerPoint. Okay, so B, again, for our formula, we need B and we need A. B is 6 and A is -3. Now, let's plug those numbers into the formula. So we have -b on top, so we have -6, and then on the bottom we have 2 times A. Our A is -3. Now we need to do multiplication of 2 times -3, -6. So we have -6 divided by -6, which is 1. So the axis of symmetry, our x coordinate, is 1. Now let's find the y value of the vertex. So again, just a reminder, once you have found the axis of symmetry, which is also known as the x coordinate, those are the same. We're going to go over that after too. But the axis of symmetry, remember, is always x equals a number. And the x coordinate of your vertex are always going to be the same. So you can plug that number into the equation to solve for the value of the vertex. So on the previous page, we found out that x equals 1. Now we're going to use that 1 and we're going to plug it in to our function wherever there's an x, right? We're evaluating this function here by plugging the number in. We're substituting the 1 in for x. So we have -3 times 1 squared plus 6 times 1 plus 5. Now, again, thinking of PEMDAS, I'll write it on the side here as a reminder. PEMDAS. So parentheses, we don't have any operations inside of parentheses, so we can just check that. Exponent, we do have an exponent. We have 1 squared, so we need to do that first. So bring down my -3. 1 squared is 1, and bring down the rest. Plus 6 times 1 plus 5. Right, so we did the exponent. M stands for multiplication. We do have some multiplication in this problem here. We have -3 times 1, and we have 6 times 1. So we have to do those next. -3 times 1 is -3. 6 times 1 is 6. And just bring down the plus 5. And now we can just solve this. You could plug this right into your calculator, exactly the way you see it, or you can use your head as well, but you're going to do -3 plus 6 plus 5, which is 8. So we found out our 2 coordinates here. Our x value is 1, and our y is 8. So that means we have to put them in as an ordered pair. Our vertex is 1, 8. So remember, in an ordered pair, x comes first, then y. And one last thing I know I mentioned it earlier, but the axis of symmetry in the vertex. Just something I want you guys to know about them is that the axis of symmetry and the x-coordinate of the vertex are the same. So let's look at what I mean over on the right. So here's the very first example that we did. We found out that the axis of symmetry was equal to -2. Remember we wrote x equals -2? Is how we wrote the answer to the axis of symmetry. Then we used that -2, we plugged it into the function, and we found out that the y-coordinate was -9. Then, in order to determine the vertex, we just took those two numbers. We took the -2 that we got, and we took the -9, and we put them into the vertex as an ordered pair. And if you notice, the x-coordinate of the vertex, so I'm going to do a different color here, the x-coordinate of the vertex and our axis of symmetry are the same, -2, -2. Let's look at the second example. So the axis of symmetry for the second example we got was 1. Our answer was x equals 1. We then used that 1 and we plugged it into the function to solve for y. And we found that y equals 8. Then we took the two numbers we got, we took 1 and 8, we put them into an ordered pair as our vertex. And our vertex was 1, 8. Again, if you notice, our axis of symmetry was 1, and our vertex, the x-coordinate of the vertex is 1. They're the same. So these should be the same. If you were to get a different number for the axis of symmetry than you did for your vertex somehow, then that would be incorrect. So just when you're doing your assignments, make sure you remember that the axis of symmetry and the x-coordinate of the vertex are the same.